All right, thank you all for joining us. This is the EMI Shielding Vent Panel Application and Design webinar. So before we start, we're just going to go over a few housekeeping details. So please let yourself to listen only mode if you haven't already. You should have joined in listen only mode. We will be taking questions at the end during our question and answer. So to submit those questions, please use the Ask Question and Answer feature on the bottom there. It's a question and answer button. You'll be able to submit questions, and then we'll be attending them after the call. And this webinar will be recorded and available for you. It takes about 24 hours, but we will get the link out to everyone who is registered, and it'll be on our website as well. So don't worry about taking notes or screenshotting. You will have this recording. So now I'd like to introduce today's speakers. Sierra, are you there?
Hello, everybody. Thanks for joining. My name is Sierra Iden, and I've been with Chomerics doing technical sales for 10 years now.
Hi, everyone. My name is Ben Noodleman. I'm a market development engineer with Chomerics, and I've been with the team for about 3.5 years.
And hello, everyone. I am Kevin Finneran. I've been a product engineer with Parker Chomerics for going on about 15 years now. And this is one of the product lines that I've handled. Welcome, everyone.
All right, so we'll get into today's agenda. We'll start with a small brief introduction about who Parker Chomerics is. Then we'll get right into the introduction of honeycomb vent panels. We'll talk about design features, performance specifications, application examples, which is always interesting to see. We'll do a final wrap up and then the all important question and answer at the end. So as you're going along, please feel free to submit your questions into the question and answer box, and we will answer them at the end of the webinar. So briefly about Parker Chomerics, we are the global leader in premier engineered material solutions. We offer core competencies in material science and process technology with a market-driven approach to both product development as well as integrated electronics housings and displays, custom engineered solutions, and global supply chain management. So with that, let's get into EMI vent panels.
So hello, everyone, and welcome again. We're going to start with a brief introduction into what EMI air vent panels are. And just as a reference, sometimes and throughout this webinar, we're actually going to refer to them as honeycomb vent panels or honeycomb air vents.
All right, everybody. So EMI air vent panels are used when you need to cool your electronics with airflow, and you need to maintain EMI shielding in now what you have a huge gaping hole in your Faraday cage. So there are a lot of things to consider, but the most important factors, in my opinion, are the shielding effectiveness and the airflow, which are both directly related to the cell size. Both have a large impact on the size, the material, the design of the vent panel itself. You need to have enough cooling and shielding of the electronics, but you should also consider when determining your airflow needs if you need air filtration of particles as well.
Some of the other factors to consider are durability and the possibility of corrosion in harsh environments that can actually have an impact on the design.
Yeah, and finally, the size of the ventilation area and added features that you may need can also have an impact on the cost and the performance, and we'll talk about those coming up.
So before we talk about some of the applications of honeycomb vent panels, let's discuss some of the design features. Honeycomb is described in terms of two different size categories. The first is cell size and actually specifies the width of the individual cells. So as you can see on the top row, the honeycomb is hexagonal in shape, and the cell size is actually the measurement across each of the individual cells. The thickness that's on the bottom row is actually a measurement of the entire sheet of honeycomb material.
So the common cell sizes are 1/8 inch cell, 1/4 inch cell. You know, we try to stick to the common off-the-shelf sizes. There is a 1/16 inch, but you want to be aware that that can really restrict your airflow, and there's also potential to clog up with dirt and dust. And then same thing with the thickness of the sheets of honeycomb. You know, we have 1/8 inch, 1/4 inch, 1/2 inch thick. You can go up to 1 inch if you need, but just, you know, if you think you might need something that's not standard, just contact us and we'll work through it. Also mentioned, cell size can have an impact on the airflow, but it can also have an impact on shielding effectiveness. So as a general trend, the smaller the cell size, the lower the airflow or the greater the pressure drop across the air vent panel. At the same time, the smaller the cell size, the better shielding effectiveness, because the smaller cell limits the amount of electromagnetic energy, passing through the opening. So the key is to find that middle ground, the largest opening to allow enough airflow to cool your system, but also the smallest cell size to block the undesired frequencies and obtain the required shielding. So it's a balancing act.
The thickness of the air vent panels actually also has an impact on both the shielding effectiveness and the airflow. So if the cell sizes were kept the same, the lower the thickness of the vent panel, the greater the actual allowable airflow. At the same time, a decreased airflow would be caused by the surface friction of the air flowing through the honeycomb vents. Reducing the vent thickness, though, will reduce the attenuation capabilities. And again, it's really just a matter of finding the ideal optimum between cell size and thickness. So we want to briefly talk about the actual honeycomb construction. Aluminum honeycomb is made of thin ribbons of bent aluminum that are adhered together using a non-conductive adhesive. And so the points at which the ribbons are adhered together with that adhesive are known as nodes. And they can actually cause some EMI leakage. With a single layer of honeycomb vents, there's actually directional EMI shielding, and it's known as the polarization principle. So what that means is if you take a look at this diagram, you have shielding in both the vertical and horizontal direction. And in this case, if you have EMI energy that's coming in the vertical direction, it can actually slide through where those non-conductive nodes are and cause some EMI leakage. So in this case, you would actually get better shielding in the horizontal direction as opposed to the vertical direction.
And it's important to note, Ben, that this is only the case with aluminum honeycomb vents, because with brass and steel vent construction, the nodes are actually welded together and therefore inherently conductive.
So one of the ways to reduce that directionality of the attenuation is actually using an omni-cell construction. So what an omni-cell construction is actually using 2 layers of honeycomb offset at a 90-degree angle. And what you'll see here in the animation is actually what we talked about with those non-conductive nodes coming together. And the directionality is actually offset by that second layer of honeycomb that you'll see coming in a second here. And what that does is by offsetting the honeycomb at a 90-degree angle, the directionality is offset and you get that shielding effectiveness in both directions.
Okay, and one downfall of that is the 2-layer will reduce the airflow. So, but omni-cell can be a great option in many cases, but for applications where potentially an omni-cell construction won't work because of your space constraints or your high attenuation needs, you can achieve the same effect by plating the honeycomb. So the plating of aluminum honeycomb in this instance will bridge the non-conductive node and eliminate the directional effect of the honeycomb. It's also a much more thorough coverage, which results in better shielding. Plating will protect the vents from corrosion and standard wear and tear. Electroless nickel is one of the most common plating options. It's a chromate conversion coating. And then lastly, EMI vents can be coated with aesthetic paints to match your enclosure design. So if you want to use a Kark paint or a common military color pattern. So you can see on the list, there's a lot of different platings and coatings. But Ben, why does the cadmium happen to have an asterisk next to it?
Yeah, so the cadmium is actually an old school technology. And while it's on a lot of prints from historical designs, and we can do cadmium plating, we actually prefer and strongly recommend that it isn't designed into new vent designs, just because it's actually a hazardous material and it can be difficult to work with some of the additional requirements.
Thanks for that. Okay, so the base material that makes up the honeycomb is an important decision that is driven by not only your shielding requirements, the potential for corrosion resistance and durability.
So aluminum is by far the most common material for honeycomb vents because of the design flexibility and cost. Using 2 layers of an aluminum honeycomb in an omni-cell design that you can see here on the second row can actually improve the shielding effectiveness while keeping costs relatively low. Adding something like an electroless nickel plating or a tin plating will noticeably increase the attenuation for higher performance.
Something to note, brass vents are made from a copper alloy and can either be plated or unplated. The base honeycomb material is thicker than aluminum, coming in at about 5 thou compared to 1.5 thou, 2 thousandths. And the frames used in brass vents will stand up much better to physical impact. So there's things to consider.
And lastly, plated steel or stainless steel vents actually provide additional robustness and corrosion resistance. So plated steel, for example, are used to provide excellent shielding, but really only within the low frequencies or the magnetic frequency ranges in the kilohertz range. While stainless steel is going to provide the best corrosion resistance. So in applications where you have harsh cleaners, salt fog, things like that, that's where stainless steel is really going to thrive.
There's a lot of added features you can end up putting onto your honeycomb vent. One is dust filters used to isolate electronic systems from airborne particulates, can be very important.
Angled honeycomb, typically at a 30, 45, or 60-degree angle, can actually provide additional privacy and obstruct a lot of the components behind the air vent panels from view. One of the other additional benefits is actually that splash protection. So if there were to be, spilled coffee or some kind of moisture or driving rain, those angled honeycombs can provide some protection there.
And protective grills can be added. There's a lot of applications where your box may be near ground level and is likely to be kicked or damaged with impact. So protective grills and also cross braces for very large vents, to keep it secured.
And lastly, one of the other added features is an intumescent coating. It's a coating that actually expands when it's exposed to fire. And so the point of the coating is that when there is a fire, for example, in a server room where there's many vents, the coating will expand, cut off the airflow, and actually protect a lot of the components inside from fire damage. And there's actually many different ways to gasket a vent panel, and you don't always need the most robust design. Sometimes it's simply just a ground between the honeycomb vent panel and the housing. So on commercial and more economical vents, a fabric over foam gasket or a combo gasket that uses a silicone or neoprene elastomer and a metal mesh strip are most commonly used.
For higher performance vents, we can use a conductive elastomer for better shielding performance and corrosion resistant applications in harsh environments. So that's something to consider.
Electrically conductive adhesives and caulks are used both in grounding of the EMI air vent panel as well as sealing interfaces with housings. And when it comes to some of the gasket attachment methods, the gaskets can be attached to vents using pressure-sensitive adhesive, non-conductive adhesives, conductive adhesives, or friction fitting a hollow O-ring into a groove. In most of the designs, we actually design the gasket into the frame and provide a one-piece solution. So it really eliminates the time for assembly and the multiple components that you have going on.
And something we wanted to briefly mention, obviously, attachment methods can be important. Threaded inserts, also called rib nuts, are commonly used to attach the air vent panels to the housings. Standoffs or bushings are also used to allow bolts of any size to be used in the frame. These are all custom designs, essentially. So you can design these to meet existing bolt hole patterns and incorporate all these things. So it's all custom. Just ask.
One of the things we wanted to talk through are some of the performance metrics of air vent panels. So as I mentioned earlier, in talking about the directionality and the polarization principle, what we have here are a couple different shielding effectiveness curves from single layer non-plated honeycomb, a non-plated omnicell or double layer design, and then a nickel plated single layer design. So on the first graph, what you'll see is actually the directionality or the polarization of the shielding in the horizontal and vertical directions, with the dotted line representing shielding in one direction and the solid line representing shielding in the other direction. Using an omnicell design and that overlapping honeycomb, you actually see that you're mitigating a lot of that directionality, but not really improving the overall shielding effectiveness of the vent itself. And finally, on the right, the nickel plated honeycomb, because that nickel plating is covering up those non-conductive nodes, you're both removing that directionality, but the nickel has that better shielding effectiveness in the range of 80 to 100 decibel.
Okay, and then there's a lot of aspects to the airflow itself, or called pressure drop, and the biggest, easiest to show is cell size versus thickness. So other aspects to note are plating, honeycomb angle, foil thickness. They all come into play. Protective grills or dust filters. But as you can see here, an 1/8 inch thick cell, we have the biggest pressure drop or decrease in airflow compared to other designs. So, make sure you're determining the top factors for design success, because you can't have everything you want. It's unobtainium. You have to pick what's most important to you.
And one other point to add here is that really the air pressure drop starts to be noticeable and have a greater effect at higher air velocities. So if you're working with airflow that isn't all that fast, oftentimes the air drop isn't a significant factor when it comes to things like cell size and thickness.
Good point, Ben. Thanks.
And finally, when it comes to the performance, one of the things that we wanted to cover is internal qualification testing. So in addition to all the historical data that we have on vent performance in different sizes and shapes, we've also done a lot of qualification testing on specific vents and specific designs. So what you see here are actually 2 different vents that are nickel plated and that incorporate a conductive elastomer gasket. And we've run them through salt fog testing and corrosion resistance testing, just so we are able to determine how the vent is going to perform in long-term applications. And we want to make sure that it's all very customer specific. So when it comes to shielding effectiveness or product reliability or corrosion resistance, as Sierra's mentioned a couple of times, reach out to us. It's a lot of the capabilities that we have in-house. And finally, we want to talk about some of the different applications where EMI air vent panels have been used successfully.
So, military electronics are running in some of the most extreme environments. It basically makes it essential for honeycomb vents. We've worked on all sorts of critical communication shelter applications, high-value cargo transport vehicles. These things all have electronics running for critical long-term scenarios. But one of the most interesting applications was the need for double angled for privacy. So they actually had double angle so that no one could see inside. There was something very special in their electronics. So, you might think that it seems crazy, but some other guy or gal already did it. So just ask.
Another application where vents are also really commonly used are actually in telecommunications application. So here you see a server room that actually incorporates a fair number of the different features within honeycomb air vent panels. Airflow is a pretty common requirement, and it tends to be very critical in these applications because it's operating at 24 hours a day, 7 days a week, 365 days a year. And the requirements that we commonly see are actually that angled honeycomb that we mentioned before, a lot of it due to the privacy of the servers and the electronics. At the same time, durability has been a pretty common driving factor, especially over the last few years. And we've seen the industry transition from aluminum to stainless steel vents. And not only for that durability, but the cosmetics of stainless steel, and that it's a much cleaner, much sharper looking design. And finally, as we mentioned before, the intumescent paints are coatings that are applied specifically to server rooms because of the potential damage and risk of a fire propagation that can have significant damage. And the last requirement really is that the vents are cleanable and replaceable. So being able to take off a vent, wipe it down, wash it down, remove all the dust, and then reincorporate it back into a design is really one of the driving factors for using more durable stainless steel vents.
And so FOD-free designs were something new to market that we created and designed several years ago and wanted to make sure you were aware of. This isn't necessarily an overall design you can pick off a list, but several different design features that you can choose and incorporate to obtain 100% FOD-free glory. So what makes it different and truly FOD-free comes down to the actual manufacturing of the frame itself and the construction and location of the mounting holes. So for instance, instead of extruding a C-shaped channel drilling through holes and plugging it with riv nuts, you might have some FOD inside. You can hear it shaking around. We would actually extrude a solid frame, drill through the material, the solid section, so then nothing could get into the non-existent channel. But reach out to us if you have, I personally have probably never walked on a manufacturing floor that didn't have a FOD-free sign up somewhere on a wall. So I'm sure you guys know that it's an important practice with design.
So Chomerics offers several different vent designs and construction to get the best airflow and shielding for the most economical design. And what you see here are just some of the trade names that we use in our different vents. And really the important takeaway is that there's a lot of different vent designs and vent features, and many of them are interchangeable based on your requirements. So the next few slides, we'll just talk about some of the common trade names and where we've seen those applications.
Right, so Stream Shield is our go-to commercial off-the-shelf vent. It's one of the only off-the-shelf or standard. And so these are typically non-structural. You see standard size muffin fans like 90 millimeter, 120 millimeter. You can have a square or circular opening. It can be offered in straight cell, omni cell. There's plated versions. It can be offered with intumescent paint. But you'd see this in a traditional telecom application where you need added shielding, or if it was necessary for just a bit more sophisticated solution than just a simple perforations or louvers in an electronic enclosure, which you've probably seen at some point.
One of the other designs that we have that's kind of in our category of versatile aluminum vents is our shield cell or omnicell design. These are typically low-end military or high-end commercial vents. They're lightweight because they're made out of either a single or a double layer of aluminum honeycomb. And they tend to use a combo gasket for mounting and mating up to a housing. With a plating that can add a higher cost, you're going to see a shielding effectiveness increase. And it can also improve the shielding of these vents, considering they're, kind of straddle the line between lower end high performance and higher end of the low performance. Finally, vents are actually going to include cross braces if they get larger than 12 by 24 inches, for example.
Okay, so there's several advantages in the higher end performance of vents of using steel or brass honeycomb. And the more obvious reason is the strength and durability. The rigid construction prevents damage from minor bumps of the honeycomb. It's honeycomb's very fragile, so it can be damaged pretty easily. Potentially eliminating the need for an added support like a kick guard or a frame brace. So steel and brass tend to be used in a lot of military enclosures, communication shelters. Anytime you hear, designing something for EMP hardening or Tempest equipment, you're going to think stainless steel or brass, especially in environmental extreme environments where, weather or salt fog, salt spray is an issue. But also a really important feature is the benefit of maximum H-field shielding effectiveness. So it can be very difficult to shield and absorb at very low frequencies with traditional EMI shielding materials. So steel is a very good candidate when I call the H word. H-field shielding is needed. So something to know.
And the other vent that's in our category of high performance vents is the co-cell design. So it's a pretty standard military offering, and it's at a higher cost, higher performance vent. It's an aluminum vent, again, with an electroless nickel plating, and it actually uses a co-seal conductive elastomer gasket to get up to 90 dB attenuation across the entire frequency spectrum. So from anywhere about 200 megahertz up to about 10 gigahertz. And finally, one of the other benefits that we see into this are the conductive epoxy, that little bead there, that actually helps ground the frame to the honeycomb. And as Sierra mentioned, the incorporation of a bushing that eliminates FOD.
So we call them VIP or shield screens, or essentially low shielding dust screens. These are specifically designed for intake or exhaust openings that require things like maximum dust arrestance, easy removal and reinstallation, repetitive cleaning of excess dust deposits. So just to confirm though, the filtering medium is not a traditional honeycomb. I know we've talked about honeycomb mostly throughout the presentation, but this is a multi-layer expanded aluminum, which can be coated with viscous oil for dust impingement, and it works in applications with very low velocity airflow.
And finally, the other low profile vent is known as a slim vent. They're made for very tightly packed or small mechanical areas. And they actually consist, also like the other design, not of a honeycomb, but of an expanded aluminum mesh. While they're thin, they can certainly provide high levels of shielding effectiveness. So up to 90 decibel attenuation at lower frequencies. And once you get up to the higher frequencies in the 50 to 70 decibel range. There will be a more noticeable air pressure drop just because the metal takes up a greater amount of the open medium. And finally, a lot of the times they'll incorporate either an EMI conductive elastomer or a metal mesh gasket for shielding.
So as you can see throughout the presentation, there are a lot of offerings, shapes and sizes galore. I mean, pick it, call us. Nothing is standard, except for probably the fan vents and the different, sizes, 90 millimeter, 120 millimeter. So the chance of you needing a custom design every time are very high, but don't fret. We have plenty of help. So contact us and our contact information is here. There's actually some pretty intricate designs we've made. I mean, if you look at this vent, it has a extremely complex machined housing. It has 2 separate vent locations. The left side is actually a hinge to be able to open and close on the box. So don't think that there's something that's unobtainium, even though I said that it could be. But do contact us because chances are your vent is going to be custom.
And with that, I think we're going to open it up to questions. So it looks like we have several questions that have already come in. Please continue asking them. We'll have Kevin weigh in from the business unit and give answers to all your technical questions.
So I have the first one from Felix. What is the lead time for product drawing release and vent size and design selection? So this is really dependent upon the type of vent. Like, as I mentioned, the fan vents are off the shelf. So it wouldn't take much time to actually design the product, get it released, and then get it on order. But something like we just showed in the very last slide with a custom machined housing, may take a little bit longer. So contact us.
One of the other questions that we've got is from Jeff. It says, do you have the capability to provide an EMI vent with removable, washable, replaceable dust filtration media? What types of filtration media is available? Kevin, do you want to weigh in on that?
Sure, Ben, no problem. Good question. So the filtration media that I think is being referred to in the question here it's a polyurethane dust filter. So it's normally measured in PPI. So we've used 30 PPI up through 60 PPI and even down to 20 PPI, which has to do with the trade-off of airflow and filtration, right? The higher PPI, the more dense the polyurethane is. So that's the most common one that we work with. Is it washable? Normally they can be blown out. We have not had any necessarily removable filters. A lot of those tend to be in the replacement filter type situation, depending on the application. From how long it's supposed to be in usage, right, depending on the type of air that's going through it. But again, polyurethane is the material that we most commonly work with, and that can be UL rated as well.
Okay, we have a question from Matt. Is stainless steel vent a good material to use? And I'll take this one. It really depends, Matt. Stainless steel can be heavier than aluminum. So if you're trying to use something like a ground-based vehicle or an automotive application, it may not be the best choice. However, if you're trying to, and not stainless steel, but steel itself for low H-field shielding is good, or for added corrosion resistance. So it's very application specific.
Another question we have from Sanjeev is, what's a typical configuration for naval applications?
Ben, if you want me to take that one, I think kind of what's behind that question is more, you're thinking in the ocean, salt fog, right? So really you're probably looking at salt fog in any type of situation, not just naval, right? So you're looking at the more corrosion resistant type vents. So obviously, kind of back to the previous question, stainless steel may be a great option. Brass, unplated or plated, as you know, copper alloy brass holds up well in those type of environments. Those are kind of the two that we most commonly see in very harsh environments. But that's not to say that e-nickel plated aluminum could also be used in salt fog type situations. So there's other factors you want to consider as well: frequency, robustness, but those are kind of the three, if you will, that in those environments we'd probably look at.
Okay. Another one from Sanjeev: does nickel plating help shielding effectiveness? So I'll say yes, it would, but Kevin, do you have any information on nickel plating at low frequencies?
So low frequencies, dealing with, I think you mentioned earlier, Sierra H field, that's typically 200 kilohertz and below. That's when you really start getting into the magnetic problems where you're kind of looking at introducing something like steel, right? Steel has iron content, which has the permeability to actually provide shielding in those lower frequencies. When you're dealing with e-nickel over aluminum, you tend to be in the above the magnetic range, right? You're not really going to get much help in the magnetic field range. But I guess the general answer to that question is yes, e-nickel plating on aluminum is going to increase your shielding effectiveness because it is going to cover those non-conductive layers, as Ben eloquently said earlier. And as that graph furthest to the right on that slide showed, you're bumping up from, I think, maybe 60, 65 dB omnicell way up to the 80 to 85, 90 dB range. There you go. Once you e-nickel plate that layer. And again, that's a single layer that's normally plated. So you're going from a double layer omnicell, and kind of the next step up is e-nickel plate aluminum. And there you go, perfect. You can see the shielding increases from there.
Kevin, we've got a question from Pete asking, is there a minimum required or recommended angled honeycomb for privacy and EMI shielding?
So there isn't, there's really no industry standard from that. So we have 30, 45, 60. Those are the three most common angles. 30 is kind of the least dramatic, if you will, right? It's the closest to the normal straight cell. So it really becomes an airflow type discussion. Obviously a 60 degree, the most dramatic, is going to give you the most privacy, right? You're gonna have to get down into the most of an angle to actually see through the cells. And it's also gonna provide the most wicking action, right, at that high angle. But again, it's going to decrease your airflow the most because now you're putting up almost a wall to the airflow. So again, it really becomes kind of that whole trade-off question between airflow, how much privacy is needed, and how much wicking action you need for moisture.
Okay, I'm going to try to kill two birds here. David, this presentation will be emailed to you, so please know that you'll get that within about 24 hours. And then from Sean, you may have missed it, but what is the thickness of the nickel? And is it electroless? And so, Kevin, you want to take that one?
Sure. So it depends on the type of application. So we normally range, I guess to back up a little bit, the e-nickel plating is AMS 2404. That's kind of the common industry spec. That's not just something we meet. It's a class 1, and normally it's 0005 minimum, which you commonly more see that in commercial applications. And we've also seen them up to 0015, so a 1.5 mil thick minimum. You tend to see that more on the higher end applications, and even some applications where there's some cosmetics involved.
Kevin, another question that we have is from Keith. Does Chomerics offer vents suitable for EMP?
So that's more of a frequency question I'll go back to. So if there's concern in the magnetic field, again, usually steel is going to be the choice. Again, due to that 200 kilohertz below. And from a shielding, just a general shielding effectiveness in those areas, I mean, you're looking at, getting below 50 kilohertz. I mean, you're really looking at 30 dB. Again, that's kind of just a general guideline, which is published in our catalog, up to maybe 60 dB or so once you kind of get towards that 200 kilohertz sealing in the magnetic field. But again, if you're dealing with magnetic fields, you're looking at steel, plated steel, and kind of go from there.
All right, we got a question from Matt. Can we get them with different gaskets? Yes, and that is what Chomerics does very well, is we make gaskets. So, definitely the gasket's going to be great. And if you look at slide 17, there's so many different types of gaskets. You don't always want to use the most expensive, high-performing gasket for a very low-performing vent. So that's something that we will help you determine what you need.
Another question from Sanjeev. Is there any data on any construction or configurations for 80 gigahertz available?
So Ben, I don't think we have any graphs to show in those higher frequencies. We don't get a lot of requests for frequencies in that range. I would say if we were presented with a situation like that, kind of the general go-to would be is to use the smallest cell size possible, right? You're dealing with the when you get to waves in those frequencies, and then probably do some testing from there. For example, the 16th-inch cell option, though you're going to get a higher pressure drop, you've now decreased that cell size to try to get better shielding. But again, that would be something you definitely want to test in the application when dealing with those frequencies.
I think I'm going to take this one. Richard, can you talk a little bit about competitive products and how Chomerics compares in regards to performance and pricing? So one thing I will say is that Chomerics, we're never going to be the cheapest people. You can buy products where, they're made in China, which is fine if that's what you need. Our vents are custom. We're going to sit down with you. We're going to understand your shielding needs. There can be things and features we can pick out of a catalog, but you are going to have the exact vent for your application with the performance needs that you need. And we're not afraid to tell you no if something doesn't look good and we don't want you to use something. So I think that's where we differ. Just our expertise, our technical people that we have to help, sampling, things like that. So I think, we definitely are a step above the rest, in my opinion.
So one of the things I wanted to go back to is, because I don't believe these animations work too well during the presentation, but just to give you a little bit of information on what the different thickness looks like for shielding effectiveness, as well as for airflow. So as you can see, the thicker the cell, the higher the shielding effectiveness that you'll see on that bottom row, but also the less of the airflow that you're going to get through it, or a higher the pressure drop. And here's a similar animation with things like cell size. So keeping the cell thickness the same, decreasing the cell size is going to give you better shielding, but again, lower airflow or a greater pressure drop across those cells.
Okay, we got 2 more questions here. Now's the time, if you have any questions, to go ahead and put them in the Q&A box. Sanjeev wants to know if there's any data for construction or configurations for 40 gigahertz. If it's available, yes, please contact us and we will help get that info for you. And follow-up question is, has Soft Shield 4850 ever been tried as a filter for the vent for EMI shielding? I believe the answer is no, Kevin. Have you ever seen that?
Yeah, not for filtration. It has been used as a gasket option, which I guess goes back to the question, do we offer other types of gaskets? And that would be normally something that would be die cut to be put on the perimeter. More commonly, I've seen that used with our stream shield vent type designs, but it definitely is an option to be used.
Excellent.
Soft Shield 3500 being the other more common option used with stream shield vents, but again, 4850 definitely.
Nice. All right, looks like that was it for questions.
So if you all do have any questions that come up after this presentation, again, by all means, please feel free to reach out to any of us. You have our contact information here on the slide, as well as going to be available once you can view the webinar online on demand.
Thank you. Yeah, thank you, Sierra, Ben, and Kevin. We appreciate your time.
You're welcome, everyone. No problem.
Thank you.
Thank you.
Thanks.